So in this video, let us go into more details of a linked list. Firstly, let's discuss what are the operations possible on a linked list. So what are the different operations that are possible on a linked list? We'll basically discuss the 5 primary operations on a linked list that can be performed. The first one is creating a list. Creating a linked list. So that's the first operation, creating a linked list. The second operation is traversing a list. The third being insertion of an element into the list. Then fourth will be deletion of an element from the list, and then the fifth one being searching in a list. So these are the 5 primary operations that can be performed on a linked list. And the first one, when I say creating a linked list, it means this, creating this initially when the list does not exist. When the list does not exist, creating a linked list basically means starting to create a list like this, which may be an empty list, like we saw in the type of linked list, which may be an empty list initially when nothing is there. Then it will be a list with one node when I create the first node with the first data element, and subsequently as I keep on adding nodes to the list is created. So creating a linked list is basically the initiation of trying to make this entire list. Then secondly, we come to traversing. Traversing means going through every node of the list. Now, if I want to go to every node of the list, please remember from our previous discussion, I need to know the header node. I need to know the name of the header node. So let's say the name of the header node is RK. So when I say RK data, I know the value is 5. When I say RK next, I know I mean this particular element or this particular node. And similarly, when I say RK next of next, I mean this particular node. So when I want to traverse a list, knowing the header node or knowing the beginning of the list is very, very important. Then we come to insertion of an element in a list. Now when we try to insert an element in a list, it is much easier than inserting an element in an array. Now what happens in an array is, in an array, let's say 2, 3, 5. I want to insert an element here. I have to push these 2 elements to the other side. Right, and then put the new element here. Okay. In the case of a linked list, it is much easier to insert an element because I am not going to move the elements around. I'm just going to change some pointers. That is, the first data element now will point to the new element, and the new element will point to the one that was already existing. We will see that in more details when we discuss operation 3. Operation 4 also is much simpler in linked list than it is in arrays, and then searching of element in a list. So these are the 5 primary operations. We will start by discussing creation of a linked list. How do we create a linked list? So let's have a look at that. As we're going to discuss this, I assume you already know how to work with structures in C, and you know what are self-referential structure. Alright, self-referential structure basically are structures that reference themselves, that have one of their elements as themselves. That is, the data type is the structure itself. So here, when I talk about creating a linked list, the first basic thing to do here is to create a node. To create a list, we need to create nodes, because a list is nothing but a collection of nodes. So how do I create this node? This node has data or info, whatever you may call it, alright, and then it has a pointer to the next node. So these are the 2 elements of a node, data and next. So I'm going to create a node. So it can be created like this from how we create structures. Struct, the name of the structure. I will name it node itself throughout all examples of linked list that we will look at. Struct node, and inside this struct node, what am I going to have? I'm going to have data. Now data depends on what you want to store. I want to store integers here, so I will say the data type of data is integers. Data. Alright, let me name it info so that I can use it throughout my example. I'm more comfortable with calling it info. Okay, int info. So the information involved in every node is integer in my case. Now the next one, if you see, we've been stressing on this, saying that this points to the next node, points to the next node. So it is a pointer, alright. Let's call it next. It is a pointer by the name next, but what does it point to? It points to the next node. So its data type has to be a node. So it will be struct node star next. Okay, so if you have missed, there is a semicolon there. Alright, so struct node star next, meaning pointer next pointing to a node. Alright, so I close this structure. This is how we create structures in C, and this is how I have just created a node. Now whenever I want to create a node or declare a member of the node, I will say struct node and then the name of the member. However, if I want to avoid using struct node every time, you know, from C, I could type define this. Alright, so I could write type def struct node node. Something like, where do I write? Okay, let me write it here. Something like type define type def struct node and the new name. Here the new name also is going to be node. Why do this? Again, there's a semicolon there, if you can see. Yeah. Why do this? So that every time I declare a member of struct node, I don't have to write struct node. I just can simply write node A, node B, not struct node A or struct node B. So that is another thing there. So here we have successfully made a structure that can be used to create nodes. See, here I have not created any node. I have just declared a structure of what should be there in a node. There should be some information involved, which is integer, and there should be a pointer to the next node. So this way I can create a number of nodes and connect them one after the other, alright, and create my linked list. So let's look at how do I take input for this node. Let's say I want to create this node. I actually want to create it, not just have the structure. Then how would I take input? So let's have a look at that. I shall do it there. I think that much space will be all right. So let's say inside main. All right. Void main, I want to create this node. So node, since I don't have to use struct node anymore, I've done type def. Let me call it RK. Node star RK. Pointer RK pointing to a node. Alright. Now I want to now create this in memory, having some value. Let's say value is 10. Alright. So how would I do that? I would say the name of the node is equal to, alright, I have to allocate memory. Now remember, this is a pointer, alright. We've not seen earlier storing values in a pointer or whatever except for addresses, alright, but I'm going to use this pointer to represent a node where it will have some data involved, some value involved, not just the address, alright. So how do I do that? I have to take this pointer and I have to allocate memory to it. Alright, now how much memory do I allocate to this pointer RK? That will depend on the size of the node. How many bytes does a node need? Alright, to be saved in memory. So I will use malloc. Alright, malloc is used to allocate memory allocation. Now malloc as parameter takes in the number of bytes you want to allocate. Here, if I say for note, what is the number of bytes? Okay, for integer I know it's 2, but for this pointer I don't know how much. Alright, so I cannot really say it on my own that I need 5 bytes, 6 bytes or 7 bytes. Alright, so what I'm going to do, I'm going to play safe and I'm going to let the compiler calculate the size of, I'm just writing it below, size of the node. I'm letting the compiler, alright, calculate the size of the node. Okay, so what just happened here? I am allocating memory to this pointer. I'm allocating memory, and how much of memory? The memory equivalent to the size of one node. Okay, of one node. Now here, malloc returns a pointer. Oh, sorry, not a pointer. Malloc returns the memory location. Alright, the memory location. Okay, so now I want malloc to return something that is of the type node, not a pointer. Alright, I don't want it to return a void pointer because that's what it does. I want it to return a pointer of the type node. Okay, so how do I do that? I have to typecast this. So I'll make a few changes in this line of code. Okay, I think I should write it a bit that side so that everything comes in one line. So I could say rk equal to, alright, I had written till now saying malloc size of node, and then that's what I did, malloc size of node. Alright, however we want malloc to return a node pointer, so now here I will cast this particular function malloc by doing this node star. So what happens, I have specifically said that whatever malloc is going to return, please translate it into the type node star so that it will be compatible with rk, which is a pointer to a node. Okay, so now in memory I have a node by the name rk. So actually in memory now a node like this is created and is given a name. It's actually created and given a name. Now how do I take input for that, or how do I store value for that? Let's have a look at it. So let's say printf enter value. Okay, so let's say I say enter a value. Alright, so now I will take input. So I say scanf %d, because I'm going to take an integer for info. Alright, ampersand. Now where do I take this value? I take it in rk, but I cannot just say rk. Rk is the entire node. I want only this data, I want only this info. Alright, so rk info. Is that alright? Yes. Why am I putting an arrow? Because rk is a pointer. You know, whenever we reference elements of a structure and the structure is a pointer, then we use an arrow. But if it is not, then we use a dot. Okay. So those are some things from structures. Then after this, I have assigned the value, alright, to the info. Now I also need to mention where does that next pointer point to. Where does the next pointer point to? rk next. Alright. In this case, since this is the first node, I don't have any node to point to. So I'll make this point to null. So this is the first and also the last node. Alright. So in this example, we have seen successfully creating a node by first declaring a structure of how our node should be, and once we've created the node, we have allocated memory and created the node, then we take input for the node and then we let it point to null since it is the only node present at the moment.